Hello, this is Mark Summers from Summers Technical Services. We're going to get started on assignment 2, which is a DIN rail, D-I-N rail. DIN is a European standard for several components, and this particular standard is for a rail that mounts electronic equipment, things like relays, power supplies, terminal blocks, etc. They use these standard size rails, and they have different sizes, different materials based on the design requirements. And so we're going to build a CAD model of one of these DIN rails. The DIN rail we're going to build is a DIN standard NS35/7.5, which means it's 35 millimeters wide, 7.5 millimeters tall. And based on the data sheet, you'll see that it's got an inside bin radius of 1 millimeter. So here's the inside bin radius here, and you'll use the inside bin radius and the material thickness that will be on the data sheet to compute what the outside bin radius is. In those bin radiuses on our CAD model, we're not going to put those into our sketch. We're going to build the sketch just like it's shown up here in the picture, and we're going to build sharp-cornered sketch, and then we're going to add the features, we're going to add the fillets as features later on. That'll make our sketch more simplified. So here's detail A we're talking about here with the inside bin radius and outside bin radius. So first thing you're going to do is go to the Phoenix Contact website and do a Google and do a search for an NS35/7.5 DIN rail. And you're not going to want to go to Mauser. You're not going to want to go to McMaster-Carr. You're not going to want to go to Newark. You're going to want to go to the manufacturer's website, which is Phoenix Contact. And you're going to find one that's made out of steel. And the length, we want to buy a length of 2,000 millimeters. And what we're going to do is we're going to cut each DIN rail. Each student's going to have a unique length. And we're going to cut those, you're going to cut those to length. But we're going to purchase one that's 2,000 millimeters long. And we're going to cut it to length. And the way we're going to cut this to length is we're going to come up with a rule to cut this DIN rail, and the rule is we're going to cut it halfway between slots. So anywhere you cut the DIN rail, we're going to say it's going to be cut right in the middle of two adjacent slots. That way the lengths of the DIN rail are going to be increments of 25 millimeters. And so we're going to have to come up with a method to calculate or to correlate the number of slots to the overall length of the DIN rail. And to do that, we're going to look at this picture down at the bottom and notice that the distance between each pair of slots is 25 millimeters. And we need to come up with an equation to define what the length of the DIN rail is in relationship to the number of slots. So the first thing we're going to do is determine what this distance is over here between the edge of the DIN rail and the first slot. And that distance is going to be, based on our rule, is going to be 25 divided by 2, which is 12.5. So we know that edge distance is going to be 12.5. So knowing that, and knowing that our number of slots is going to be related to L by this method. We know that this is a 25 distance. So there's one 25, there's another 25, and another 25. So there's 1, 2, 3 25s to go from the first slot to this last slot. And there's 4 slots, 3 spaces, so we know that the equation for L is going to be n minus 1. In this case, 4 slots minus 1 is 3. So n minus 1 times 25 will get us from here to here. And then we need to add to that, to get L, we need to add a 12.5 on the left end and a 12.5 on the right end. And so this value here is just 25. So I've got n minus 1 25s plus another 25. And so that just tells me that L is always going to be equal to n number of slots times 25. So if I solve that for n, I'll see that the length, or the number of slots, is just going to be L divided by 25. And we're going to use that for our parametric model we're going to build so that we can correlate the length of NREL, whatever your length happens to be, to the number of slots. So now that we understand the parameters we're going to build our model to, let's go see how we're going to build this CAD model using Solidworks.